everyone, and welcome back for another deep dive. Today we're going to be looking at voltmeters and how to use them properly in a DC circuit.
Sounds pretty technical.
It is.
But it's really interesting stuff.
It is. And to help us out, we've got this awesome interactive simulation called Where to Connect the Voltmeters from Open Educational Resources.
Catchy open source physics at Singapore.
It's a really neat tool for anyone who wants to wrap their head around this.
Definitely.
So what's great about this applet is that it really focuses on this key principle, which is that voltmeters need to be connected in parallel.
Right.
Not in series to get an accurate reading.
Exactly.
Okay, so let's unpack this whole parallel thing for our listener.
Okay.
What exactly does that mean in terms of how we hook up the voltmeter?
So imagine you're connecting the voltmeter across the component you're trying to measure.
Okay.
Like laying a bridge over it, rather than inserting it directly into the path of the circuit.
Okay.
That's parallel. Connecting it in series would be like adding another stop along the circuit's route. Which messes up the readings.
That makes sense.
Yeah.
And the simulation lets you actually play around with this, right?
Absolutely.
So you can drag the voltmeter around the circuit and see the digital readout change depending on where you put it.
In real time.
Yes.
It's a great way to really visualize how this all works.
Yeah. I noticed something interesting when I was playing with the simulation.
Oh, yeah.
When you drag the voltmeter outside of the cells in the circuit, the reading just drops to 0 volts.
Right.
Why is that?
Well, that's because voltage is all about measuring the difference in electrical potential between 2 points.
Okay.
So if you're not measuring across something with a potential difference, like if you're outside the power source of the circuit, there's no voltage to detect.
So it's like the simulation is showing us that you need that complete path for the electricity to flow to actually have voltage. Exactly. Without a closed loop, there's no flow of current and no potential difference to measure. And this simulation even has a power button.
Oh, cool.
That you can turn on and off to kind of drive this point home.
So it's mimicking a real-world scenario where you're turning the circuit on and off.
Yeah.
That makes a lot of sense.
Yeah.
But what I really thought was cool was this question combo box feature.
Oh, yeah.
It's like having a tutor built right into the simulation.
I agree. It's really clever.
Yeah.
It's a good way to guide people as they're learning.
So when you select an option from the combo box, it not only moves the voltmeter to a specific spot,
right,
but it also gives you this pop-up explanation for why that position is important.
Yeah.
And it makes you think about what's happening.
Yeah, encourages you to think critically.
Yeah. It's like the simulation is walking you through different scenarios and explaining the reasoning behind each one.
I like that.
It's really well designed.
It is.
And it shows how powerful visuals and clear explanations can be for learning.
Absolutely.
And what's even cooler is that this is just one of many physics and math simulations.
Oh, wow.
Available on the website.
That's awesome.
Yeah. Open educational resources, open source physics at Singapore.
They've been busy.
Yeah, they have a whole library of these resources.
Wow.
Which is fantastic for making STEM education more accessible.
So important.
I want to pause for a second, check in with our listener.
Okay.
Think about what we've learned so far.
Okay.
This whole idea of connecting a voltmeter in parallel.
Right.
And how voltage is really about potential difference. How could you imagine these principles applying to something like the electrical system in your house? It's more complex, sure.
Yeah.
But the fundamental ideas are the same.
That's a good point.
Yeah.
It's a great question to consider.
And even in a more complicated system, you'll still find those core concepts of parallel connections and potential differences at play.
Absolutely.
That's what makes this simulation so valuable.
For sure. It gives you a really solid foundation to build on.
Exactly.
Okay, so we've talked about the big picture ideas.
Yeah.
But I want to kind of zoom in a little.
Okay.
And dig into some of the specifics that make this simulation so effective.
Sounds good.
One thing I really liked was how it has this step-by-step guide right in the simulation.
Oh, right.
You remember those instructions for dragging the voltmeter and seeing how the readings change?
Yeah.
I think those are super helpful for making sure that even someone who's never used a voltmeter can still navigate the simulation and get those core concepts.
Totally. It's like having a virtual lab partner guiding you through the experiment.
And speaking of virtual labs, this applet really bridges that gap between theory and practice. It lets users safely experiment in this virtual environment, which is great for students who are just starting out with electrical circuits.
Yeah. Takes away that fear of making mistakes.
Yeah.
Makes it a more relaxed experience.
Exactly.
More exploratory.
And let's not forget about that aha moment.
Oh, yeah.
When the voltmeter reading drops to 0
Right.
outside the cells.
It's so visual, right?
Yeah, it's such a powerful visual demonstration of how you need a complete circuit for voltage.
Absolutely. The simulation uses visuals really well to kind of reinforce those key learning points.
Yeah, like the changes in the voltmeter reading, plus that color-coded power button really makes it easy to see the connection between a complete circuit and voltage.
Makes it really clear.
This simulation isn't just, presenting information.
Right.
It's actively guiding users to understand the concepts.
I agree.
Yeah, I completely agree.
What do you think about that?
The way it's set up with the questions and the explanations in the interactive experience really gets you engaging with the material.
Yeah.
You have to think critically
Right.
of why certain placements
lead to certain readings, and it just solidifies your understanding.
Yeah, especially like how the combo box gives you all these different scenarios and then explains them clearly.
It's tailored for each choice.
Yeah.
It's like having a personal tutor.
Yeah.
Right there.
Right in the simulation.
Yeah.
It really shows how carefully they planned it.
Yeah, absolutely.
Remember when we were talking about all those resources on their website?
Oh, yeah.
It's incredible to think this voltmeter simulation is just one of them.
It's amazing.
It really shows their commitment to open access education.
Yeah, for sure.
Providing all these resources to people everywhere.
To everyone.
Regardless of background or location.
Yeah, it's really inspiring.
Okay, before we wrap up this part, let's just do a quick recap for our listener.
This sounds good.
First and foremost, a voltmeter has to be connected.
Yeah.
In parallel to the circuit component you want to measure.
Exactly.
This is key to getting accurate readings. Parallel connection, not series connection. That's the rule.
The golden rule.
Of voltage measurement.
Yeah.
What else should we highlight?
I think it's important to remember that voltage is a measure of the potential difference between 2 points.
Right.
So if there's no potential difference, like when you measure outside the cells, there's no voltage.
It's all connected.
It is.
And this applet does a brilliant job of showing that.
Clearly and in a really fun way.
Before we move on,
Okay.
I want to ask you, dear listener, something to think about.
Okay.
We've been looking at a very simple DC circuit.
Right.
How do you think these principles might apply to something much more complex?
Like what?
Like the electrical system of a car.
That's interesting.
It might seem like a big leap,
Yeah.
but the underlying principles are the same.
Yeah, even as the systems get more complicated.
Exactly. So we started with this little applet about connecting a voltmeter.
Yeah.
But we've gone way beyond that. Talking about circuits.
Yeah.
Electricity, even like the whole world of STEM.
It's all connected.
It is.
It's amazing how one little thing can lead to so much.
It really shows that knowledge builds layer by layer.
You start with those basic principles, and you just keep building from there.
So before we finish up, I'm wondering about other ways we could use this voltmeter simulation. It's obviously great for a single lesson.
Right.
But I bet teachers could use it in like a flipped classroom.
That's a good idea.
Where students could explore it at home.
Yeah.
And then come to class ready for discussion.
That would be cool.
I love that because it puts the students in charge.
Totally. It's active learning.
Yeah.
They really take ownership of what they're learning.
And beyond the classroom, I think this simulation would be awesome for anyone who wants to learn about electronics, hobbyists, people who like DIY projects, even professionals who need a refresher.
I bet a lot of people would find it helpful.
It really shows you that learning doesn't have to be formal.
Exactly.
It can happen anywhere as long as you're curious.
That's the key.
What do you think is the most important thing for our listener to take away from this deep dive?
That's a tough one.
It is.
I think it's that feeling of wonder and excitement.
Oh, yeah.
You learn something new and you just get it. Hold on to that feeling.
Yeah.
It's a reminder that learning should be fun.
Absolutely.
It's an adventure.
Yeah.
A journey of discovery that never really ends.
So well said. And the more we learn, the more we realize how much more there is to learn.
It's true.
So keep asking questions.
Yes.
Keep experimenting.
Yeah.
And keep that curiosity alive.
Absolutely.
And that brings us to the end of our deep dive
already
into the world of voltmeters
and DC circuits.
We hope you've enjoyed it.
Me too.
We'll see you next time for another deep dive.
Bye, everyone.